So now we're going to talk a little bit about some of the blockchain fundamentals. These are kind of the building blocks that we need to cover before we get into the details of how the technology works. So let's go ahead and get started with that. So just as a little bit of a review, blockchain is a digital ledger. Transactions are recorded chronologically. They're available to the blockchain participants, which could be public or permissioned. People all over the world are using blockchain-based vendor or open source products. The most common use of blockchain technology is cryptocurrencies, and there are many other uses of blockchain technology. And so if we were in person, we would have a conversation about why does blockchain enable some of these new capabilities that were not possible before. There are a couple of different types of blockchain. We talked about private and public, or permissioned and permissionless. There's also another type that's commonly referred to as a consortium. It's sort of a blend. If you think about maybe like an industry association, right? You've got to be a member of sort of this wide group, but once you're a member of that wide group, it feels and acts like a permissioned blockchain. Bitcoin and Ethereum are public or permissionless blockchains. Hyperledger, R3 Corda are examples of private blockchains or permissioned blockchains. The Dragon Chain would be an example of like a consortium, sort of like a blend in between. It's important to understand that the different blockchains have different industry focuses. They have different governance mechanisms and governance organizations. They've got different types of, in this case, they're all the same in this slide, but many of the different blockchains have different types of ledger types. Some of them have tokens or a currency, some of them don't. There's a whole lot of different differentiators between the different blockchains that ought to be used to help to decide which blockchain to use for your project. There's also blockchain as a service. So this is when a third party installs and maintains a blockchain network for companies' technologies. So think of this as a cloud, but for blockchain. It helps businesses develop and host blockchain apps and smart contracts in a blockchain ecosystem. It's typically managed and administered by some kind of cloud-based service providers. Microsoft, Azure, AWS, IBM, Oracle, Ardor. These are all examples of different types of blockchain as a service offerings. Just again, just to review the features: security, privacy. These are decentralized systems, transparency, consensus, cryptographically safe and secure ecosystems, and immutable transactions. These are all sort of features. You'll see this diagram all over the web. And I don't think either of these diagrams really do this conversation justice. So I'm going to sort of talk through the three terms and explain the three terms. And the pictures somewhat describe the terms, but not perfectly. And incidentally, when we talk about centralized, decentralized, and distributed, that may refer to decision making, or it may relate to engineering, right? And so that's why these terms are somewhat a little confusing, because when you're using a term, it depends on whether you're talking about the architecture or you're talking about the authority, right? They're just slightly different. But centralized, whether you're talking about architecture or authority, means that you have one person that essentially is making decisions, or one group of people that are making decisions for the whole network. In terms of architecture, all of the data resides on one place, and it might be copied to other locations, but it's made in one place, and then essentially it has a one-way communication out to the other nodes. Now, I'm going to do distributed first. A distributed system means that everything's not residing in one place, right? That the information, the content, and even the decision making is distributed amongst many different places. Meaning, if any one node went down, the risk of loss is distributed amongst many different nodes or persons, right? Decentralized means that no single point has control over any other single point, right? So you could have a distributed database, in which case there's copies of the database in many, many different places, but the control could still be centralized. Or you could have a database where it's distributed, meaning you have copies in many, many different places, but there's no single entity that controls the decision making, in which case that would be decentralized. So if you're talking about decision making, is the decision making centralized or decentralized, right? Does it reside in the hands of one person or a few people, or is it really very democratic, done by voting in elections, and nobody can really manipulate or control the decision making, right? The other scenario is decision making is centralized, right? So, and there's advantages and disadvantages to both. And think about it as the difference between a military command structure and a Congress, right? So a military command structure would be like a centralized structure. Centralized organizations can sometimes be extremely efficient, right? The owners can move very quickly. Procedures can be very structured and not available to interpretation, but it generally requires trust in the central authority, right? Whether you have the trust or not, it does require a strong central authority. Decentralized, so think of a Congress, right? It's hard to get things through Congress, but that's because whatever does get through Congress is generally going to be pretty good, because it's just not one person's opinion. It is a consensus among a number of people, and those people typically will represent even a larger number. So the idea is typically that something that's centralized is going to be faster, but it may not be as well thought out, whereas something that's decentralized is going to be slower, but ideally more well thought out or more representative of the wider community. Decentralized can be very bureaucratic and slow, has lots of layers, can often bog things down with too many steps. It can stifle innovation. So there's clearly, from an innovation standpoint, a big difference between being in a centralized versus a decentralized scenario. Now, a centralized scenario can stifle innovation too. It all depends on the centralized authority, what their opinion of the innovation is, whether they support it or oppose it. But the decentralized scenario can become non-competitive and non-scalable, and does not necessarily require a trusted third party. The trust is distributed and decentralized among the participants. Now, let's talk a little bit about just some concepts before we get into talking about how the technology works. The first concept is encryption. We're going to need to understand this before we talk about what the hash is. And the hash is a fundamental part of blockchain. What encryption means is we're going to take data and we're going to scramble it using some kind of an algorithm or a function at either the word or the letter level. And it's going to generate some kind of ciphertext that can only be read if you have essentially the key to decrypt it, right? So it's going to be, ones and zeros or numbers and letters. It's going to appear random and not make any sense. It'll just kind of look like gobbledygook. And of course, the security of the encryption can be enhanced if that function, that function or algorithm that's going to take some kind of structured data and scramble it, if it also does it randomly, meaning if the way it scrambles A, B, C, D would be radically different from the way it would scramble A, B, C, C, or A, B, C, E, right? So randomness is a big part of it. And theoretically, it is possible to break it. It's possible to break into an encrypted system with a supercomputer, but it's very, very difficult. And it uses something called authorized keys. So we talked a little earlier about a private public key pair. So that's kind of what it uses. We also have the concept of authentication methods, right? If you're going to use a trusted third party, how are some ways that you can authenticate that something is true and real? You can use a notary public, a financial institution, a government office. These are typically referred to as authentication methods or authentication bodies. And then the last couple concepts we're going to talk about is consensus mechanisms. The most common one that we hear about is proof of work or proof of stake. And proof of work it's a protocol. It's a function. It's like an equation. And what it was used for initially was when websites first started getting put up, bad actors were trying to knock them down by using something called a denial of service attack. And what that means is, if you had a website and I wanted to knock it down, I could just send so many messages to that website to completely overwhelm its ability to process requests, right? That it would not be available to process anybody else's request. So if I was sending messages to your username and password login screen, and I was just trying attempt after attempt after attempt, and I would have hundreds of computers or thousands of computers sending messages to try to log in username and passwords. It didn't matter whether they were correct or not correct, right? At a certain point, your website would not be able to even answer the questions, right? And that's what's referred to as a denial of service attack. So the whole idea behind a proof of work is before that message gets to my website, your computer has to solve some kind of a problem or a puzzle. And it makes your computer have to work at something. And when it works at something, it basically is using an economic resource. It's using energy, it's using cycle times, it's using its computing power essentially to do work. And the whole idea is to slow down the incoming messages so that you can't effectively do a denial of service attack, right? A key feature of this of proof of work is asymmetry, which means it's difficult, hard, but feasible in order to do the work, but it's very, very easy to check to see whether the work was done correctly or not. So think of it as of having a problem question or statement, and then somebody else having the answer key. It might take you a while to figure out the problem, but once you figure out the problem, if somebody's got the answer key, they can very quickly say it's correct or it's not correct. And this concept is also known as CPU cost function. A puzzle, a computational puzzle. These are all different ways that it's expressed. It's different than a CAPTCHA, which is intended for a human to solve quickly. This is purely done only by a computer. So proof of bandwidth, proof of stakes, proof of ownership. There's a gazillion different types of consensus models or mechanisms. You can Google them and find all kinds of, and people are making up new ones all the time. All right. So the next thing that we're going to get into is what's in a hash, which is the foundation for the blockchain technology, which we're about to walk through. So I'll see you in the next module.